2O5. What is that? Alright, so you split this into phosphorus. Yeah, you have 2 phosphorus there. Penta. So plus 2. No, plus 5. Plus O minus 2. Yeah, you're right. Diphosphorus pentaoxide. And then the next one, CaOH2. We can split this as Ca plus 2 plus O at OH minus. Okay, so that is just calcium hydroxide. Yeah, you don't need to put that one because that is the charge of calcium. So that is calcium hydroxide. Then the next one, CrCl2, and the other one HCl NO3 HNO3. So CrCl2. What is Cr? Okay, so you split this to Cr plus 2, Cl minus. Yes, all right. Because metals, Cr here has variable charges, so we need a Roman numeral. So this is chromium 2 chloride. Then HCl split into H plus Cl minus. You have H in front. Hydrogen plus chlorine, right? So you have hydro plus the root of the non-metal here, so plus ic for the acid. So this would become hydrochloric acid. Yeah. Yeah. But if it is indicated that it is a gas, then you can say hydrogen chloride. If it's aqueous like this, so hydrochloric acid. But normally we name this as hydrochloric acid. Then NO3. NO3 without a charge. Huh? It doesn't have a charge, right? So maybe we can just say nitrate ion. This is alone. But it doesn't have a charge here. It doesn't have a charge, right? Only NO3. Yeah, but then from your problem here, paper is only NO3. Yeah. So, but okay, we will just do nitrate ion. Supposedly this is neutral nitrate. Okay, so just to nitrate ion, then HNO3. Yeah, you split this. Okay. So you have hydrogen in front and nitrate ion, NO3 minus. So that means this is an acid. Hydrogen plus polyatomic ion. with oxygen. So nitrate, it would become nitric acid. Yeah, so this is nitric acid. Okay, then the next one, you write the formula. Sodium nitrate. Okay, how do you write that? It's nitrate. Yeah. So the charge of sodium is +1, plus nitrite is NO2. So this is NaNO3. Oh, NaNO2. Sodium nitrite. Okay. Excuse me. Alright. Then dinitrogen heptafluoride. Hepta, so you have 7 fluorine there, 2 nitrogen. Then ammonium sulfate. What is the charge of sulfate? Ammonium is NH4 plus. Sulfate, okay, so this is NH4 to SO4, ammonium sulfate. You forgot your 2. NH4 2, you have 2 molecules of NH4. Then silver oxide, okay, Ag plus O minus 2. Okay, so that is silver 2 oxide, but okay, Ag2O. What should be silver silver 2 oxide? Silver 1 oxide. Silver 1 oxide. Okay, it's not this one. You don't need to write the numerator. It should be AgO only. Then sulfuric, oh, it's Ag2O. But the name is silver oxide, silver 1. You don't need, since the Roman numeral is only 1, then you don't need to write it. Silver oxide. And then sulfuric acid. Okay. SO4. Because you change you change ATE to IC. Okay? OUS to from ITE to OUS, right? And then ATE to IC. You have here sulfate, so that is sulfuric acid HSO4. So H2SO4. Yeah, you have to memorize all of those. Yeah. Your exam is tomorrow? Okay, we go to the next one, next problem, next paper. The density of silver. So density is 10.5 grams per milliliters. How many silver atoms? Silver atoms are contained in 25.0 ml sample. So when we say atoms, we will use the Avogadro's number. We're given the density and we're given the volume of the solution, the volume of silver. So we need to find the mass first. So mass is equal to the density times the volume. That is 10.5 grams. Did you solve this? Try solving this. Times 25 ml. Yes. Okay, let me write this clearly. So mass, this is just like dimensional analysis. So just work on the units and make sure to cancel those units that you don't need and then leave the unit that you need. So we need the mass here. So we can multiply the density, which is in grams per milliliter, so that is 10.5 grams per milliliters, times the given volume, which is 25 milliliters. And that cancels out the unit milliliters, and we'll be left with grams. So what is the mass? You can use your calculator. 10.5 times 25. Okay, so 262.5 grams of silver. Yeah. And then what is the molar mass of silver? Because we need that. Molar mass of silver from the periodic table in grams per mole. 8682, so 87 grams per mole. Then we divide this one, the mass that we just calculated, so that is 262.5 grams divided by 107.87 grams per mole to solve for the number of moles of silver. So grams here cancel out. Grams cancel out, then we'll be left with moles. So 262.5 divided by 107.87. What did you get? Okay, 2.433 moles of silver. But the one that is asked in the problem is how many silver atoms? Yeah, so we convert this to atoms. Mole silver, we convert that to atoms. Okay, let me delete this. So we have 2.433 mole silver. We convert to atoms, so we multiply this by the Avogadro's number, 6.022 times 10 to the 23rd. Yeah, 23rd atoms per 1 mole silver. We'll be left with atoms because the mole unit here cancels out. So what is 2.433 times 6.022 times 10 to the 23rd? What do you get? Okay, 1.466. Okay, 1.4654. So 1.465. Maybe we'll just 1.47 times 10 to the 24th atoms silver. Okay, so a 25 milliliter sample of silver contains about 1.47 times 10 to the 24 atoms. Okay, no questions in that? Alright, so let's go to the second one, the next problem. An aqueous solution is 17.3% by mass CaCl2. This is calcium chloride and has a density of 1.19 grams per milliliters. How many milliliter of solution needed? Okay, needed to supply 3.88 times 10 to the 24 chloride ions. All right, so in solving problems like this, you need to take note of the given values. So we're given here 17.3% by mass calcium chloride, the density, and the number of ions. Yeah, 3.88 times 10 to the 24th chloride ions. And we are asked for the volume of the solution that we need to supply this 3.88 times 10 to the 24 chloride ions. Okay, so we can start from this one, the given ions of chlorine. We get the number of moles. So that is 3.88 times 10 to the 24 ions, right? Times, we get the number of moles. 1 mole of chlorine, so ions of chlorine, 1 mole of chlorine per, we divide by the Avogadro's number, times 10 to the 23rd ions. Okay, so what is that? 3.88 times 10 to the 24 divided by 6.022 times 10 to the 23rd. What did you get? Okay, 6.443 moles chlorine. Okay, and then it is stated here that the moles of calcium chloride, here CaCl2, we are required 2 chlorine ions from CaCl2. Yeah, so we can multiply this by the mole ratio of, oh, okay, we do like this, 6.443 moles chlorine times the mole ratio, so 1 mole of CaCl2 per 2 moles of chlorine, right? Then the number of moles of chlorine cancels out because we are asked for the solution CaCl2, not the chlorine alone. So we get the number of moles of CaCl2, so that is divide 2, so that's 3.2215 mole CaCl2. So now we already have the number of moles of CaCl2. We can get the mass of CaCl2. What is the molar mass of CaCl2? We get you get the molar mass of CaCl2 first. Molar mass of CaCl2. Calcium plus 2 times chlorine. Okay, 110.984, so 98 grams per mole. So now we can calculate the mass of calcium chloride. So from here, from the number of moles we got, 3.2215 moles calcium chloride, we multiply this by 110.98 grams calcium chloride per 1 mole calcium chloride. So we get the mass. Let me delete this. Okay, so 357.551, 52, 53. Okay, 5, maybe just 53 grams CaCl2. Okay, so now we already have the mass. We are asked for the ml, but we're given here 17.3% by mass CaCl2. So we can divide this by 17.3%. Yeah, so we divide this by 17.3%. We convert that to mass, divide by 100. So 17.3 divided by 100, because that's in percent. We need to convert that. Is that 0.173? Yeah. So this is just the mass of solution. Yes. Yes. So divide 0.173. What did you get? How come I get different? Okay, I think there's something wrong with this. Yeah, that's right. 2066 point something, 0.6 grams of solution, a CaCl2. But then, okay, take note that we are asked for the ml, milliliters of the solution. So you convert grams to milliliters. We convert that. So 2000, we're given the density, right? Okay, so that's the use of the density there. So 2066.6 grams. We divide this by the density to get the volume. So this is divided by 1.19 grams per milliliters. The gram unit here cancels out. So 2066.6 divide 1.19. What did you get? Okay, 1736.64. Let's write this in scientific notation. 1.74 times 10 cube milliliters, right? Or we divide that by 1000. That is 1.74 liters. But we are only asked in milliliters. So the answer should be 1.74 times 10 cube. Because we write this in scientific notation, our answer is 1736, right? We write that in scientific notation. Yeah, 1, 2, 3. In writing the rules in writing scientific notation, the number should be less than 10. Less than 10. All right. I think that's the last paper. Yes, you still have more there. Oh, I see. So whenever you solve problems like this, you take note of the given values first, and then you start from the last given value, and then you convert all the units.